Hello everyone. So in this video, we're going to do a quick overview of rocks. And these are the two lesson goals for this video. You should be able to explain the differences between minerals and rocks, and as well as to describe the basis used to classify rocks into three principal classes. So let's begin with the definition of a rock. So a rock is a coherent, naturally occurring solid that consists of an aggregate of minerals, or less common, a body of glass. Okay, so that's really the difference between rocks and minerals. Rocks are basically a body, a natural solid body that consists of, it can be a single mineral, or most commonly it consists of multiple minerals in it. Okay, so a rock doesn't have a definable chemical composition, whereas minerals, they do have definable chemical composition. Okay, rocks are very important for us because, whenever we try to make infrastructures, for example here the rails for the trains, we have to consider what type of rocks we got nearby. Or obviously we all know that because of the strength of the rocks, people built buildings out of rocks, right? For many, many years. So there are three major types of rocks. The first one is called the igneous rocks. The second one is called the sedimentary rocks. And the third one is called the metamorphic rocks. Now, for both the igneous and metamorphic rocks, the interlocking crystals of minerals are the ones that hold the rocks together. And that's the reason why we get a solid rocks for igneous and metamorphic rocks. Okay. However, in sedimentary rocks, the system is a bit different because sedimentary rocks are basically, most commonly, they consist of reworked fragments of rocks, such as sand grains, for example. Here in clastic rocks, they're held together by cement. So if we zoom in into these rocks right here, we would probably get something like this under microscopes. And these reddish areas here, they represent individual grains of sand. And in between those individual grains of sand, we have something that we call as cement. And this cement acts like a glue that basically hold those individual grains together, creating a nice body of sedimentary rocks. Okay? And again, this is something we're going to talk a little bit more when we talk about sedimentary rocks. And this is the chemical composition of rocks. And again, these terms always occur. Silicate minerals, okay? Silicate minerals are the most abundant in Earth's crust, consisting of oxygen element and silicon element. Okay, so the way we classify rocks into those three types, or those three classes of rocks, is simply based on how they form. Okay, so rocks are classified by their origin. For example, igneous rocks form from molten material. So for in this case is that we have lava that just, it looks like it just comes out of a volcano, and these lava will start to solidify and becomes igneous rocks because of the drop of temperature. Okay. Um, the next one is sedimentary rocks. Sedimentary rocks formed by precipitation and or these processes right here. Okay. So when it forms by precipitation, it will start to form a something that we call as chemical sedimentary rocks, such as salt deposits, for example. But it can also include these activities right here, or not activities, these processes here that will create something that we call as clastic sedimentary rocks. Clastic sedimentary rocks are a type of sedimentary rocks that consists of reworked fragments of any pre-existing rocks. Okay, so it involves erosions and weathering of pre-existing rocks, and those processes will create sediments, and those sediments will be transported and then dumped and accumulate into sites of sedimentary basins and got buried. Okay, and eventually cementation and compaction processes take place to create sediments, to basically change sediments to become sedimentary rocks. Okay, and again, we will talk about those processes when we talk about sedimentary rocks later on. And the third one is called metamorphic rocks. Metamorphic rocks form when we have pre-existing rocks undergo changes in pressure and temperature. Pressure and temperature. Okay, typically it involves increases in pressure and temperature, and that's basically the characteristics of a process called metamorphisms. Okay, so metamorphisms typically involves increases in pressure and temperature, and when you have that process, then you will likely to have metamorphic rocks that we see here. And this picture right here kind of shows you the different types of environments that can create different types of rocks on Earth. If we start from sedimentary rocks, they typically involve surface processes, so such as erosions and transportation. And the erosions and weathering will create or will produce sediments, and those sediments will be dumped into sedimentary basins, such as right here or right there or here in the ocean. Okay, and when they accumulate, and they will start to get buried, and they will start to change, and they will start to become sedimentary rocks eventually. And the second one is metamorphic rocks. And again, as I mentioned earlier, metamorphisms involve increases in pressure and temperature. Okay, and a great environment to actually have a high pressure and temperature would be somewhere here. This is a collisional zone between two continents. So this continent and that continent, when they come together and collide, they will create a very extreme pressure right in the middle, and obviously when that happens, the temperature will also increase, and that's the reason why these mountain belts are typically sites for the formation of metamorphic rocks. And the last one is igneous rocks. Igneous rocks are pretty straightforward. Whenever you see these hot red materials, that indicates lava or magma, the presence of lava or magma, then you will likely to get igneous rocks. So here in the mid-oceanic ridges, we typically have volcanic activity as well as around volcanoes, obviously. All right, so for the next couple slides, I'm going to show you what are the physical characteristics that we see as geologists to identify rocks. The very first thing is that we look at the grain size. We also look at the grain shape. Okay, and when we say grains, we actually use the word grain very loosely here, because grains can be mineral grains, and it can also be rock fragments or glass fragments. Okay, whatever those things are, even as long as there are loose particles, we could call them grains. But here in this example, this is one of the ways we classify the sizes of those grains. Okay, and again, we're going to talk about this when we talk about sedimentary rocks later on. The other two characteristics that we look at is the composition as well as the texture. The composition is very important, especially for igneous rocks or metamorphic rocks, and that's practically the way we classify these rocks. We look at the composition of these rocks. And the other one is the texture. The texture refers to the configuration of grains in a rock, okay, or the configuration of minerals in the rock, and how those grains connect. Okay, again, this is also another important aspect of the rocks that we use to identify what type of rocks they are. We also look at the layerings of rocks and the foliation of rocks. Okay, so layering and foliation, they look very similar, but they are produced by completely different processes. Layering is typically associated with sedimentary rocks that looks like a stack of rocks like this. Okay. And we look at the different composition of these layers and the grain sizes, the textures or the structures or the alignment of grains. Okay. And for foliation, now foliation is defined by alignment of minerals within metamorphic rocks. Here you can see the layers or the beddings here are very continuous. You can actually trace this one layer all the way to the other side of the photo. But for foliation, it's very hard to trace those alignment of minerals. So for example, if I want to trace this white minerals here, I will trace it over here, over there, and then somehow it gets very thin and it just dies out. Okay, and that is a characteristic of a foliation. It does show some alignment, but the alignment is not very continuous. Sometimes it just dies out like this. Okay, so those are layering or beddings in sedimentary rocks and foliation in metamorphic rocks. And those are some of the things that we look at as geologists to identify minerals, to identify what type of rocks they are, and to identify how they form. And I think that's it for this video, and I'll see you again in the next video. Bye bye now.